Welcome back. Now, today we're going to talk about angled projectiles. Before we talked about projectiles that were launched horizontally, right? And we did this, and it went like so. This is a horizontal projectile. But now we need to talk about a projectile that's launched from here, and it launches, and it goes back here. So notice here, this is going to be our angled projectile. So, looks like that. For today's lesson, once again, I have my helper here, Skylar.
Hi.
Okay, and I imagine she's probably going to draw something at the end for us again today. So, we're going to combine some things. We've done, the last video was, we had to do some little bit of trigonometry. We're going to use that trigonometry, combine it with our physics, and bam, we will have our angled projectiles. So, let's get started. So, let's take a... let's say somebody kicks a ball, right? So let's say we've got our flat space right there, and someone's going to kick a ball, and it's going to obviously travel in that path. What's the shape of this path? Skylar, do you remember the shape of this path?
A semicircle?
Oh, that's close. It is kind of like a semicircle, but not quite. It's called a parabola. This is a parabolic path. It's a parabola. Parabola. Okay, it's a parabolic path that it goes in. So here's what we're going to do for this. Let me give you this initial velocity. Let me say it's at initial velocity. Oh, let's call it 10 meters per second. But notice that it's 10 meters per second at some angle. So let's say this angle here, let's call this angle theta. Let's call it 30 degrees, because why not? So what I'm saying is my initial velocity is 10 meters per second at 30 degrees above the horizontal. Please note, this is not VI in the Y. This is not VI in the X. It's really both of them. Okay, it's both of them combined. We have to break it up into X and Y. Okay, this is critical. We are going to have to break this into an X problem and a Y problem. So the first question I'm going to ask is, what is the maximum height of this projectile? So before I find this, I said this is an X and a Y problem. So what I have to do is I need to find my initial velocity in both the X and the Y direction. If my initial velocity is 10 meters per second, and this is 30 degrees, I need to find my Vx, and I need to find my Vy initial. Okay? Because this is a right triangle, I have my angle, here's my hypotenuse, my Vy, remember from SOHCAHTOA, is going to be Vi sine theta, which makes Vx Vi cosine theta. So let's get some numbers for these things. Let's find the Y first. My initial velocity is 10 meters per second. My angle is 30 degrees. So we got 10 meters per second. The sine of 30 is 1/2. You are in degree mode, yes? I hope so. So it's 5 meters per second. This tells us my initial velocity in the Y direction is 5 meters per second. Okay? This is critical. We need this. We are not going to use this 10 meters per second anymore. We're only going to use this 5 meters per second and what I get for my Vx. So this is 10 meters per second cosine 30 degrees. So it's 10 meters per second, 0.866. So we've got 8.67 meters per second. Okay? These are our initial velocities, Vi on the X. We are not going to use this 10 for this problem. We're going to use this one and this one. This is either an x problem or a y problem. So the question was, what is the maximum height of the projectile? If I'm looking for height, clearly it's y, right? If I'm using the y, I'm using the big 5. So if I want max height, that's my delta y. So now, initial velocity, final velocity, acceleration, time. It's the exact same problems we've been doing before. If I'm looking for max height, that's my unknown. My initial velocity. Be very careful. It's not 10, it's 5, because I'm only worried about the y direction. Meters per second. Final velocity. This one's a little tricky. If I'm looking for the maximum height, the final velocity at the maximum height is 0 meters per second. Acceleration due to gravity, it is vertical, so I get minus 10 meters per second per second. Time is absent. So if that's my guy, I got Vf squared equals Vi squared plus 2a delta y. Vf squared is 0, so I got minus Vi squared all over 2a equals delta y. I'm just plugging numbers in. So I got minus 5 meters per second squared all over 2 times minus 10 meters per second per second. This gives me a maximum height. Well, I got 110 here for some reason. I don't care about that. This gives me a 25 divided by 20 gives me 1.25 meters. This is the maximum height. Okay, we can find more stuff though. Let's find more. So, under our same conditions, right? Under the same thing, right? I got this 10 meter per second launch projectile, 30 degrees. Let's find the total time of flight. So, if I want to find the total time of flight, remember, we have to ask ourselves, is this something I can do with the x or something I can do with the y? Well, interestingly, you can use either, but it depends what information we have. So we don't have enough stuff in the x, so we have to use the y. Let's write down what we know. Initial velocity, final velocity, acceleration, delta y in time. Time is my unknown. Initial velocity, it is not 10, it is 5 meters per second because I'm using the y stuff. Final velocity, if I want the total time of flight, it's when it starts to when it finishes, right? So the final velocity has to be minus 5 meters per second. Acceleration, minus 10. Delta y is 0. If it starts and lands at the same y position, we have a 0 displacement, which makes this much easier. I have 4 things. Fantastic, which means I can use any one I want to use. So let's find time is our change in velocity over acceleration. V final minus V initial all over acceleration. Final is minus 5 meters per second, minus 5 meters per second, all over minus 10 meters per second per second. Oh, look at this. Gives me a time of 1 second. It is in the air for exactly 1 second. All right, let's find another thing. This is going swimmingly. All right, let's find, how about the horizontal range? So if I want to find the horizontal range, this horizontal tells me x. The great news about the x, you guessed it, I've only got one equation. So all we need to use is this, delta x over t. If I'm looking for delta x, it's my velocity times time. Now, be careful again. What velocity am I using? I'm not using 10. And I'm not using 5. I'm using my horizontal velocity. I figured out my horizontal velocity to be 8.67. 8.67 meters per second. My time of flight is the same as what I did before. It's 1 second. So 8.67 meters. Boom. All right. Let's find one more thing. Okay, so let's think about this conceptually. I know the ball is here, it goes in its path, it comes back down again. So I know that the ball hits the ground with a velocity going in that direction. I also know that it has a horizontal component and it has a vertical component. So let's look at this. The horizontal component initially was 8.67, right? This 8.67 meters per second horizontally. Let's take a look back here. There is no acceleration in the x direction. If there's no acceleration in the x direction, my velocity in the x direction remains constant. So my x component of velocity is 8.67 meters per second, no matter where I am. Okay, great news. So then what about my final velocity in the y direction? What's this? Well, we actually did this already. We said here my final velocity in the y direction is minus 5. If it goes up with 5, it should come down with minus 5. This is fantastic news. How easy physics is. Minus 5 meters per second. If I know what this is, and I know what this is, I know what this is. But I don't even have to do that either. Because how did I get these numbers? I got this, and I got this from this. So this has to be 10 meters per second. Lastly, I need an angle. If I know that this is a right angle, I know that this is 10, I know this is 5 and 8.67, this angle has to be 30 degrees. However, 30 degrees is up this way. This is down this way, which makes this angle minus 30 degrees. So my final velocity is 10 meters per second at a minus 30 degrees. All right. So all these we were going to do problems like this in class. This is how you're going to be able to hit me with a water balloon. This is super exciting. So there's a lot of trigonometry here, but it's the same principles we've been using all along. So that's all I got. I think Skylar has a picture she wants to draw for you, and that's all. I will see you in class. What are you drawing now?
Circles.
Just circles?
Yes.
Is this what you were doing in art class in school?
Yes. I was doing circles in art class at school.
Just circles? That's more of an ellipse. Do you know what an ellipse is?
No.
Kind of like an oval. Skylar was student of the month at Germantown Elementary School.
Yeah, and that is where I go. How do you change the thing?
What do you want to change?
The color, because I have one for
Oh, you gotta press and hold it.
Okay.
What happens when you're student of the month at Germantown Elementary?
It means that I was being respectful, responsible, and safe.
And what do you get? What do you get for that?
A prize.
You get a prize?
Uh-huh.
Like what kind of prize?
I don't know because I've never been the student of the month.
We're gonna find out tomorrow, though, right?
Yeah.
You get to meet the principal.
Uh-huh. a very small circle.
Yeah. Do these represent anything? Or are they just circles? Oh. They're people. Oh, it's a sad person. What?
It's supposed to be a bird.
A what?
A bird.
Oh, a bird. Why is the bird sad?
It's supposed to be a beak.
Oh, a beak.
Yeah. This is an egg.
That's an egg? Okay. What's this one? Oh, that beak looks better. The pointy one.
This is also an egg.
That's also an egg too?
Yes.
Okay.
Now I need to get blue.
Oh, very nice. Is this like a family of birds?
Yes.
Is there a mommy and a daddy bird?
This is the daddy, but
Your
this
point
is
with
the
this?
mommy.
So which one's the mommy and daddy?
This is the daddy right here. This is the mommy.
And who's this?
This is the sister. These are the two eggs.
Oh, okay. Very nice. All right. Thanks a lot.
Bye bye.